So, artificial analysis have introduced 6 new capability indices for comparing model capabilities across some different industries. Now, artificial analysis have been putting out a good number of benchmarks to help us assess the capability of AI agents as they increase their capability over time. But these new indices are pretty interesting because they combine underlying benchmarks into new occupation specific capability indices. This is a bit of a departure from how we've thought about benchmarks in the past, where we're going beyond the point where AI agents, can they do the task, to can they actually do the task in a way that someone working in an industry could. So this builds on things like the GDP val indices and the AI benchmark indexes and other things that artificial analysis have been putting out over the last few months. So you can see here that they've put this index together on a basis of the ONET occupational classifications, which also underlie the GDP val benchmark. And their results are in line with what we're seeing in other benchmarks at the moment. Claude Fable 5 leading all 8 indices, Claude Opus 4.8 in second, and GPT 5.5 high on 2. What is more interesting to me, and something that I've been talking about a lot on this channel and in my writing over on Substack, is the increased capability of the open weight models. GLM 5.2 is leading on 5 of the 6 industry indices and ranking as high as 5th overall on some of the industry-specific indices. Now, it's quite a bit behind where the Claude Fable model is, but this is showing us that the gap between frontier models that are closed and open source models is much, much smaller than a lot of people are aware of, unless they're looking at these or they're doing their own experimentation with the models themselves. So over on the artificial analysis website, you can see the different capability indices that they've put together. There's an agentic index, a coding index, a finance and accounting index, a strategy and operations index, a legal index, a healthcare and medical index, an engineering index, and an economics index. But how have they actually put this together? So I mentioned in the introduction that they are combining a number of different benchmarks, and in this document here, they outline what they're doing. So each index is made up of a combination of different benchmarks. So the agentic index here is a 50-50 split between agentic knowledge work measured by the GDP val AA benchmark and 50% agentic customer interaction measured by the Tau banking benchmark. And if we scroll down, we can see that for each of the different indices, based on the tasks that someone is likely to be working on in that domain, a different weighting to the most relevant benchmark has been attached. So each index effectively has an allocation across the benchmarks that reflects the allocation of typical tasks for people working in that index. For example, you can see here the legal index has a much higher weighting to the legal knowledge benchmark AA Omniscience. If we look at how they've put together one index, the Finance and Accounting Index, you can see on this index page they have the component benchmarks, related links to all the other indexes, a methodology which goes through those weightings that we saw on the last page, and the specific score for this index, which, as you see, looks very similar to other rankings, which suggests as models are better and have higher capability, their capability on all manner of tasks rises, but the specific rankings of each model are slightly different depending on the different benchmark weightings reflecting the actual tasks that are happening under the hood. What this also breaks out is the capability breakdown across the different types of tasks by model. And what you can see is that each model, depending on the task, has slightly different sub-capabilities. So if you hover over these index values here, it breaks down where that score is coming from. And you can see that models with lower scores have higher ratings than some models that it scores ahead of, which is kind of funny. We can look here at Minimax M3. It has an overall score of 34 on this index, but its agentic knowledge work score is 45, yet the model that scores 1 point more, Kimi 2.6, has an agentic knowledge work index of just 35. This capability breakdown section goes further and is a cleaner way, I think, to look at the different levels of performance. So you can see the business knowledge performance, the agentic knowledge work performance, the reasoning performance, the agentic customer interaction performance, the long context performance, and non-hallucination performance. Similar to how artificial analysis are sharing some of their other indices and the underlying data that goes into these calculations, they have representative workflows here which explain the sorts of tasks that the model is assessing. So for example, this financial analysis and reporting task is assessing business knowledge, reasoning, long context, and non-hallucination. In the example, build a same-day EBITDA bridge. So it is a task that someone in a financial analysis and reporting team could very much be asked to do. This way of thinking about how we assess AI agent capability is much more important than just knowing whether or not an AI tool can give a response to a question you ask it, and is a really important thing for us to be monitoring as we watch AI agent behavior evolve and delegate more and more complex tasks to AI agents in our businesses. This chart here shows the index versus the release date of the model. And you can see over here the more recently released models are scoring higher, but also you can see that some models released recently are not improving that much, because you can see these are some of the open source ones that are sitting well behind that closed sourced frontier. Now, one of the things I've been writing about on my Substack quite a lot is about the cost efficiency of different models, and how much it costs to execute a task is one of the more important metrics if you're thinking about what proportion of tasks are done by humans and what proportion of tasks are done by AI agents inside your operating model. You can see in this chart here, the Anthropic models score very highly, but they are very expensive on a per task basis. And this is where looking on a scatterplot of index score versus cost per task helps us realize the real power of some of these open source models. If for your needs, the performance of these models is good enough or near enough, they represent very good value for money. The issue is that in many of these work-related domains, any errors at all could have cost of error that are well in excess of the cost per task here. We also need to understand the frequency of some of these tasks. If you're spending $3 per task and that task has to happen hundreds of thousands of times a week, that ends up being a very expensive API bill for you if you're selecting Anthropic to execute those agentic workflows. Understanding these trade-offs is what's flowing in to all the things you're seeing in the news about companies looking at their AI API spend and really trying to figure out, are we getting value for money here? Should we be sending more agentic workflows to open source models? Just because a model is smarter, should we always be using that particular model? One of the other ways to think about the cost effectiveness of a model is the total cost of running the index. So how much does it cost artificial analysis to run all of these underlying tasks to calculate the subscores and total scores in this index? You can see here the Anthropic models again are very expensive. So it's costing them almost $5,000 to execute this benchmark. Whereas at the other end of the scale, on a reasonably well-performing model like GLM 5.2, it costs just $695 to execute all of these tasks. Again, this is where this cost versus capability trade-off is becoming one of the most important battlegrounds in how enterprises are selecting and deploying which models they use in their business. If you're thinking about using AI agents in your operating model, speed matters as well. And this index also looks at the time per task. This is in minutes, and lower is better. And if you look here, some of these models are taking quite a bit of time to deliver the outcome. Again, just to pick open source favorite at the moment, GLM 5.2, it takes 2.7 minutes, whereas Claude Fable 5 takes 6.8 minutes. And when you're thinking about the overall running costs and how many tasks you can execute in a given time window, again, just like the cost versus capability trade-off, all of these speed issues are more and more a consideration when enterprises are looking to deploy AI in their business. We can look at this score versus time per task and this most attractive quadrant, the green quadrant here. You can see where Claude Fable 5 actually falls inside this optimum spot. But look over here at the performance of GPT 5.5 on extra high reasoning. Its time per task is only 2.3 minutes and it scores 46. This is still quite a bit below Claude Fable 5, but it shows that the speed at which GPT 5.5 is being served can be a consideration if you're thinking about which workflows go to OpenAI versus which workflows go to Anthropic. Output tokens are the other underlying part of this. So how many tokens are used to run one task broken down by reasoning and answer tokens. And if you look at this, there's an interesting outcome where Claude Sonnet 5 is the most verbose. It's using all of these tokens, whereas Claude Fable 5 is more token efficient, using literally half of the tokens that its cheaper and less capable model is delivering. GLM 5.2 uses a surprisingly high number of tokens, but GPT 5.5, and again, if we look at the index value versus output tokens per task, we can see in this green spot over here, GPT 5.5x high is sitting there, but Claude Fable 5 is way out over here because it's quite verbose in the number of tokens it's using. In each of these sector benchmarks, artificial analysis have a number of frequently asked questions that you can take a look at. I'll put a link to this in the description below. You can see here for strategy and operations, legal, healthcare and medical, engineering, and economics. All of these benchmarks help people working or with customers in these sectors to understand for the tasks being done in these industries how agentic capability is evolving. So here, just to quickly look at the economics index, some of the representative workflows here: build a forecasting workbook in Python that ingests several FRED data series to run a baseline ARIMA model, chart the projections, and produce a short written interpretation of the outputs. So all of these benchmarks over time, as agentic models get better, are going to get saturated. And what that means is inside these specific domains, more tasks and bundles of tasks are better done by an AI agent than a human expert. We're still a ways off a lot of these benchmarks being saturated. But as you can see, as each model generation gets shipped, more and more of these tasks are more easily executed at a level of quality the same or higher that a professional in these domains would be able to deliver. So in this video, I've covered off how these different capability indices are structured and had a bit of a chat about what I think about their construction and what it means. Just to recap, I think these are quite an important contribution to our ability to track how agentic behavior in the workplace is evolving, and also compare what that cost versus token use or cost versus capability is looking like. A lot of companies are getting quite concerned about their token spend, so they really want to know if there are models out there that can help do the work that they need to get done at a much cheaper price point. And when you think about how this is built on the ONET occupational classifications and all of the tasks, like in things like the GDP Val benchmark, what it means is that that end distribution of which tasks go to which model is going to turn on where in these scatter plots models are falling. If they have that right blend of cost and capability, then more and more tasks will be pushed to those models, and only the most complex tasks where your acceptable failure rates are extremely low, or you can wait for a longer time to get an acceptable answer, will go to the more expensive models like the Claude Fables. This blend is no different to how you might allocate tasks in a team of differing ability and experience. And thinking like this shows how much the sophistication of the AI agent task allocation space has evolved just in 2026 so far. More and more benchmarks like this are going to be coming out over the next few years, but I look forward to seeing how this artificial analysis capability indices series evolves, especially because at some point, some of the underlying benchmarks that they're going to be using are going to get saturated themselves. So they're going to need to come up with a way to replace or evolve how they're tracking some of those bundles of tasks as AI agents get better and are able to deliver much better results.